Hey guys, Pankaj here. Welcome back to my YouTube channel. So today I'm going to talk about another plotting library that is very famous and very heavily used in data science. Okay, so its name is Seaborn. So you have already got the idea now, like how to do basic plotting in Matplotlib, how to edit the various properties of the plots. Okay, so on top of that, an advanced library is Seaborn. So in Seaborn, you will be able to do a lot of data visualization in a very short span of time, and you can do any kind of plot very easily, okay, without writing multiple lines of code. Okay, so let's go to the topic, and I'm going to share my screen. Okay, so these are the topic I'm going to cover under Seaborn. So we'll see a lot of various plot which we have already seen in Matplotlib, but how easily you can plot and what are other factor behind Seaborn to use it, correct? So the main reason of Seaborn plotting, why I'm telling to use, or maybe in future if you are going to use it, right? So you stick to Seaborn because of two reasons, or maybe one solid reason is, so in Matplotlib, right, you have seen at least in 2D plot you can plot max two variable, right, x and y, correct? In case of Seaborn, you can plot at least 4 to max 5 dimension of data in single 2D plot. Okay, so I'm going to show this along with the example, then you will understand what I mean to say about like 4 or 5 dimension of data in one single 2D plot. Okay, so that is the beauty of Seaborn. So let me start like what and all I'm going to cover today. So we'll see what is the base library for plotting Seaborn data, and what are the various data set available in Seaborn library. So you don't have to load externally. Seaborn itself provide a lot of toy data set. I think 15 to 20 data sets are there, so which we'll see shortly. Okay, so how to do various plotting, how to change various plotting style of Seaborn. Then we'll see different plots. Okay, count plot, bar plot, line plot, histogram, distribution plot. Okay, ECDF, that is nothing but empirical cumulative distribution function plot. Then we'll see scatter, then box plot, then Boxenplot. Okay, then we'll see what is swarm plot and how to do that. Violin plot also, then Stripplot, pair plot, and Heatmap. Heatmap is a very important plot because you are going to use it very heavily day to day, because once you start learning machine learning, there is something called confusion matrix. Okay, so once you do data prediction, you need to basically showcase using data visualization. Okay, so their heat map will be the best plot for showing confusion matrix. Okay, so let's get started without wasting time. So what is the library which we are going to import? So first I'll import numpy as np. I may use some random data, that's why I'm importing numpy. Then import pandas as pd. So panda also will be used in case we are going to generate data frame using random data of numpy generated data. Okay, then next is import matplot lib.pyplot as plt. So why matplotlib? Because though we are going to see one, but as I mentioned, it is written on top of matplotlib, right? So in case any specific editing of the properties of the data or editing the properties of the graph you want to do, then plt will be the right way to do that. Okay, then the main library is Seaborn. So import Seaborn as SNS. Okay, so you can use any name as alias, but SNS is very standard and widely used, so that's why I'm using same name. Okay, so let's run it and load all the libraries. Okay, so all libraries are loaded. So after library is loaded, right, so there are two ways to get the data. Either you download from external website or using Google also. And instead of downloading from external data, you can use Seaborn library itself to load one of the toy data. Okay, so let's see what and all toy data set is provided by Seaborn. So under SNS, we have one function called get dataset. Okay, so let me see what is the exact name. There is something called get dataset. Get dataset names. Okay, so what I'll do now. So let's see what and all datasets already available. So we have anagram, then enscombe, attention, then brain network, car crashes, diamonds, dots, exercise, flights, fMRI, then gammas, geyser, iris. So there are a lot of data. Okay, so we may see a couple of them, but maybe for today's example, I may use a very small, and the best one is you can use Titanic as well, but Titanic I'm going to use it for case study, so I'm not going to show this data today. Rather, I'll use tips. Okay, so this tips data, what it does basically. So when people go to a restaurant, right? So they have lunch or dinner, they do or smoking, non-smoker people will also be there, right? How much tip they are paying on top of whatever is the final bill, correct? So that kind of data is collected and put under tips data set. Okay. Similarly, we have iris data set. This is related to flower, petal length and sepal length and width, and their various species. Then we have something called MPG. This is automotive data. So different kind of different kind of what to say car and their different kind of engines. It is 4-stroke engine, 3-stroke engine, like that we have. Okay, and when it was manufactured, and whether it is 2-tire or 3-tire, all those details are captured under MPG data. So I think after completing this video, you guys just go through each data and understand and just explore it. Okay, so as I mentioned, I'll be using tips. Okay, so let's see how to load the data of tips. So df equal to SNS. It is already maintained in the form of table data, so I can directly get the data frame. So we have load data set, and what is the name of data? That is nothing but tips. Just give the name. Okay, and df dot head 5. Okay, so we have total bill, tip, then gender, smoker, day, time, and size. Okay, so smoker is like whether they are smoking or non-smoking. Day means I think all 4 or 5 weekdays they have considered, like Monday, Tuesday, Sunday, and Saturday. And time is like lunch and dinner. And size is nothing but like people size. How many people went for dinner? How many people went for lunch? Okay, and how much total bill they paid. So this is just example data. And on top of total bill, how much tip they paid. Okay, and whether they were male or female. So these kind of data this is very good data set for playing with the data and do a lot of visualization around it. Okay, so our data is loaded now. Let's see a couple of other things which is provided by Seaborn. So in Matplotlib we saw like it was just plotting 2D and in the white background, right? So there also you can control a different kind of background in Matplotlib, but here it is made easy. So let's see what and all styles are supported. So SNS dot, we have one function called set style. So if you are not sure about style, just give some random name. Okay, so just run it. So if you are giving some wrong name, it will show like what and all style will be supported. So we have white, dark, white gradient, dark gradient. So let's talk about these 4 and we'll set it whenever it is needed. I'll just put it as comment, and I'm going to set right now, which is by default as white. Okay, so let it be white and later we'll control it. Okay, so now we are set. We have data set and we have background data also. Okay, so now let's see the first graph, that is count plot. So if you have seen bar plot in Matplotlib, right, what it does, it takes one particular category and how many counts of those values are there. That is kind of shown as in the bar plot. So same kind of thing can be done in Seaborn using count plot. So let's see the data now. So what I will do, head 2. So I'll be using this head 2 very frequently because as screen we are going down, right? We may get the data hidden. So I'll just get the idea like what and all features are there, columns are there. So let's see the count. So first we'll see like how many male and female were there, right? So what we can do, SNS dot count plot. And if you see help of any kind of plot, right, it has a lot of parameters supported. So what is your X data? What is your Y data? What is hue? This is the dimension I was talking. Okay, so hue is nothing but, let's say, your third variable. So X and Y data is plotted, right? Now based on some category, those X, Y data is different. Basically Y data is different, right? So that hue can be taken as a third parameter or third dimension data. Okay, so accordingly all the data will be segregated and plotted based on those categories. Okay, so this data or parameter will be very helpful where you have a lot of categorical data in your data set. So let's go with just plot df dot 6. Okay, you see here it is by default plotting male, female, and see it has automatically given X title and Y title also. Okay, so I think I have not shown in Matplotlib, but this is very important and very easily you can do that. So maybe what I'll do, I'll just show one example here. plt dot plot bar plot, and here we have df dot okay, this is not the count, right? So what we can have here, df dot okay, so this is the way you can get total count, and you can just do the plotting using pandas default plot. Okay, so plt you can just give kind equal to bar. That's how we plotted, right? Let it come. Yeah, so if you plot like this, either using matplotlib or pandas default plot, it is just going to show the data, but it is not going to show the title, right? So explicitly you have to mention like plt dot x label. So I can give x label as, let's say, gender. Okay, so now gender is coming, right? Similarly, you can have y label as count, and you can give y, and here you can have plt dot title. This thing I have not shown, but I'm just showing you right away so that you can understand how this labeling is done. So title is nothing but gender count. Okay, so you are all set. You are giving x label, y label, as well as overall title of the graph. Okay, so same thing is being done here as well as in the Seaborn, but this is happening automatically. How? Because you are giving this particular data, right? So it is automatically fetching the category name of the data, and accordingly it is showing the data. But overall title is not present, so it doesn't mean like you are using Seaborn you will not be able to set the title for the graph. You can still do that, because as I mentioned, it is written on top of Matplotlib. So all the graph axes and other thing will remain same. So plt dot title, I can mention gender count. Okay, so all remains same. So this is the way you do the count plot. Let's talk about bar plot. Okay, so again I'll take df dot head to. So let's see what SNS bar plot does. See here, it is also having a lot of data. Okay, so I'm not going to play around all the parameter. Whenever it is required, we can play, but topmost required data parameter we'll be using. So what it does, show point estimates and confidence interval as rectangular bars. Okay, so here I'll just take x equal. There are two ways to do that. So either you can use df dot, let's say, again I want maybe smoker. Okay, so x-axis will be a smoker, and their count will be df dot, let's say I have total bill. Okay, so this is the first two parameter, right? X and Y. So if you are not mentioning using keyworded argument, that's fine. So by default, it will be taken as X. So let's mention it. So always mention whenever you already have keyworded argument. Okay, so it will be more readable. That is a good practice. Okay, so if you do this plotting, so with smoker, like whether it smokes or doesn't smoke, and what is their total count. Okay, so along with this, for those who are smoking, they are paying max 20 bill. Okay, bill amount is 20, and those who are non-smoking, they are paying very close to 20. Okay, that's what you see here. And in the bar plot, whatever you see, right, this particular line, this is nothing but your error line. So if you see here, By default it shows. If you don't want to show, you can just move it. Okay, so here there's something called error color, right? So you can just remove it by controlling the width. So I don't want to show the width, so you can just make it none or 0. So we see here, error width is the float value, thickness of error, bar lines and caps. Okay, so let me just control in another graph. Yeah, so by default it is having some float value of that width, that's why it is shown here. If you make it 0, it will not be shown. Okay, so that's about bar plot. Now let's talk about adding more number of parameter in the same graph. Okay, so as I mentioned, the beauty of Seaborn is you can plot multi-dimensional data in 2D plot. Okay, so how to go with multi-dimension? So let's talk about, we have one parameter called hue, right? So hue is the parameter which will add the dimension or more dimension in the graph. Okay, so let's get what other categorical value we have. So under smoker, total bill, let's talk about those who are male or female, right? So what I'll do, under hue, I'll add df.6. Okay. So it will take the category of gender, that is male and female. For each category, it will plot your total bill as well as smoker, whether it is yes or no. So we have yes, smoker, yes, no. And those who smokes, we have male candidate more, female candidate less. Or basically the bill which is paid by male is more, and bill which is paid by female is little less than male. Okay, so that's what you can infer from this particular graph. Okay, so this is about adding hue or adding third dimension in the graph. Okay, so we'll see one more example, maybe under scatter plot, where we can add fourth dimension also. Now let's talk about line plot. So SNS dot line plot. So we have, let's say X, I want total bill, maybe that should be index, and Y value should be, so index basically for each value, right? So the first value, nothing but 0th index, and second value is first index, like that. And for each index, I want this, the total bill. This index I'm talking 0 and 1. Okay, and Y value should be, let's say df dot total bill. Okay, so let's see the line plot. Yeah, so that's how your, but it doesn't make any sense, but I'm just showing you how the line plot works and how you can plot it. Okay, so here it is very dense, so let's control the figure size. So now we have loaded plt dot figure. Under that we have fixed size equal to 16 by 4. Okay, so like that you can do the line plotting. So here you see automatically y label has been already put as total bill, because this is what we have provided. Okay, and index is not a label, so that's why you don't see any label here. If by chance if you would have given some other category, numerical value graph detail, then it would have taken the X title also. Okay, so that's about line plot. We lot of details here. So again, here also hue parameters. Hue will be there almost all the plot of line. So let's see how this line is varying based on those who are, let's say we have df dot head 2. Okay, so let's add one more dimension here. So I want to see this kind of total bill trend for time wise. Okay, so those who are going for lunch and dinner. So hue parameter will be df dot time. Okay, so your one data will be lunch, one data will be for dinner. Okay, so that's how it is getting plotted. Okay, then we have some other parameter like line color, and you want to have dotted line now, which we have already seen in matplotlib. So you guys can play with that and make more or beautify your graphs. Next is histogram. Okay, so let's remove this one. So histogram, as I mentioned, it is nothing but it shows the value, how many times it is occurring, okay, or basically occurrence of the element, or how frequently or how many number of times that element is occurring from the data set. Okay, so df dot head to, so let's see, we plot. So where is the numerical value? We have, let's say, size, right? So sns dot hist plot df dot size. So object type numpy integer 64. What is this? Okay, maybe I can give y equal to, or maybe df equal to df, then y equal to total bill. Okay, and if I make it here, yeah. So here hist excuse me. So here in the hist plot, we are giving the data. So there are, as I mentioned, two ways to plot, right? Either you give the dot nation of data frame, or you directly give the data equal to your data frame, and x and y parameter, you can just give the column name of the data. Okay, so I want to see histogram of total bill. So if you see here, right, the bill amount which was frequently paid or more number of time it is paid, that is nothing but which is varying between, let's say, 20 or maybe 15 to 16. That's why you see the peak here, right? And out of total bill, it is occurring almost close to 48 times. Okay, that's what you infer from the histogram. Let's see what other parameter we have. So definitely we will be having hue parameter, because I can have a histogram plot for the male as well as female. Correct. So let's see. Yeah, we do have equal to, I will just give, so I'm not giving df dot sex. Why? Because I have already given data type as df. Correct. So now two histogram will be plotted for male and female. You see here, and automatically color will be controlled. So let's go with default color. Why? Because SNS in Seaborn library, they have already given those default color, which is widely accepted. Okay, so you don't have to really control it. Now let's see the next one, distribution plot. So SNS dot dist plot, what it does. So flexibly plot a univariate distribution of observation. Okay, so this is nothing but a kernel density estimation. Okay, which is kind of histogram plot, but it will just plot a line. Okay, so here what I want, df dot total bill. Yeah, so this is what we saw here, right, for the total bill. Okay, and this is internally by default, it does basically a estimation kernel density estimation plot. What is KD? I will explain in the statistics. Okay, so under that graph, like how your data is distributed, that will also getting plotted here. Okay, so if you see, there's one parameter called hist or distribution, which will make it false or true. So hist is true here, right? If you are making hist equal to false, it is not going to plot this, because we have already plotted in the histogram. Correct. So in case you don't want, you just make it false. Okay, now next is, let's say, hue. So this time I would like to make hue as df dot daywise. So we have 4 days, right? So for each day it is going to plot. Got an unexpected. Okay, why it is not taking? Oh, it doesn't have a hue parameter. Okay. So do we have KD plot? Let me just check. Okay, it is there, right? So there we can play. And I'm going to give exactly same thing. Yeah, this will work. Okay, so let me use this KD plot, kernel density plot, kernel density estimation. Okay, so here this is nothing but exactly same as distribution plot, but here we have hue parameter, which is very important. Okay, so let's say you have a lot of categorical value and how your data is distributed across, between certain range. So with that, it will be very helpful, and you can easily visualize your data. Okay, so this will also help you to easily get like what is your mean, and what is your percentage of data out of total data or total population, how it is centered between the mean. Okay, and how many such values are there which is centered between the mean. Okay, so which you will get to know a little more once I explain the statistics. Okay, so that's how you do distribution plot as well as uh, kernel density estimation. Okay, so under distribution we have one more parameter called rug. Okay, so rug is nothing but if you just make it true, right? So it is going to show all the data just below the peak, okay, or just below the line, whatever is plotted in the distribution plot. And it is just show like how dense your value is there. As I mentioned, more values are centered across this peak, right? So you see more density and how your data is dispersed around the tail of the distribution plot. Okay, so you can make that true, you can control the color as well. Okay, so that's about distribution plot and KD plot. Let's see the Ecdf plot. Ecdf is nothing but empirical cumulative distribution plot function. Okay, so what exactly it does, right? Whatever values you have, right, it will take all cumulative sum and it will just plot in the data in the graph. So we do have direct function for this SNS dot Ecdf plot. When you want to see something cumulative, then go with this df dot. Let's say I have total bill. Okay, so if you would have taken histogram, then it will plot in the bar graph, right? So there you may have to do some smoothing and all, but here it is not required. Internally it has been taken care, and that's how it is showing the cumulative bill. Okay, what else we have under this? Yeah, we have hue parameter also, so you can control the hue by adding another dimension. So let's say hue, I want to add df dot male and female. Why it is not taking again? Okay, so what I will do, I'll just, whenever you get this kind of problem, right? So better you give data equal to your df. Okay, and your x is nothing but total bill, or maybe df dot index, and y is nothing but total bill, and hue is your gender. So, or not, oh, bivariate is not plotted. Okay, then I can just either go with x or y. I'll go with y. Okay, so this is for male and female. You can see here proportion, how the proportion is distributed, right? So for male you have more, and for female it is little less. That's what you have exactly seen in the bar plot also. You see here in the total bill, for male it is more, female it is less. Okay, so there are various plotting. Whenever it is required, based on that you can take whichever you want for your project. Let's go with the scatter plot. So SNS dot, before that let me get data. Okay, so SNS dot scatter plot. Okay, so again it needs x, so x I'll give df dot index, and for each index I would like to have total bill, how it is distributed. So df dot total bill. Okay, that's good. Let's control the figure size. plt dot figure to 16 by 4. plt dot show. Okay, so scatter plot is plotted. Now let's add some more beautiful things about scatter. Okay, so now here I'll show how you can add 4-dimension data in your single 2D plot. Okay, so what other parameter we have? So index total will we have already given. So let's talk about male and female data, how it is distributed. Okay, so I'll give hue parameter as df dot sex. Okay, so you can see automatically color coded will happen. So orange color is female and blue color is for female male. Okay, so that's how your data is distributed. So if you see right clearly, blue data is little more. Okay, and orange data is little less than blue one. So this is one dimension. Let's add another dimension here. Okay, so now this time I would like to add different markers also. So now 3-dimension added, 4-dimension I'll add. Markers will be, let's say, I want to control, we have something called day, right? D of day. So let's add another dimension, that is 4-dimension as a day. So so total 4 kind of day we have: Sunday, Monday, Tuesday, or Wednesday. Let's see. Okay. So for between these data set, right, which data is particularly for Monday or Sunday, Saturday, or Friday. Okay. So we have something called markers. Okay, let me take another one. So guys, remember we are going to add, or we are about to add 4-dimension in this 2D plot. Okay, so we have something called markers equal to, or maybe style I'll give equal to df dot day. Okay, you see here automatically Thursday, Friday, Saturday, Sunday is added. So index total will 2-dimension. 3rd-dimension is your gender, that is male and female, and 4th-dimension is how your data is distributed across Thursday, Friday, Saturday, and Sunday. Okay, so that is the beauty of Seaborn. So let me add here. Now let's add something more. So you would like to control this one. You would like to control the size, right? So size also I can give size equal to df dot team size. Let's go with that, whether it is able to add or not. I think it is able to add. Okay, only thing is factor is little small, so maybe I'll try to multiply by 20. No. Okay, it is taken some default size. Okay, no issue. I'm going to add now marker style markers. So if you see by default, it is taking Thursday as circle, Friday as cross, Saturday as square, and Sunday as plus sign, right? So I can define my own markers equal to, so let's say I want to have big diamond and big hexagon. And let's say I want to have star and I want to have P. P is nothing but plus sign. Okay, so that also you can do. So accordingly, it will be taken and it will be showing all the data. So now you understand. I hope you like this particular graph and Seaborn library, and I suggest you start using it and keep applying this particular graphing library in your data. Okay. Now let's see the box plot. So box plot is very important whenever you talk about data analysis. Okay. And whenever you are going to do some kind of statistical analysis for data, this is one of the best plot and one of the first plot you will be using. Okay, so let's talk about df dot head to. So here we'll be using df dot box plot. So for box plot, I'm going to plot total bill. So df dot total bill. So unexpected, okay. It is just needing the data, or not df. It was correct. It should be Seaborn SNS. Okay, so this is a box plot. So how it works basically, you will be taking the full data, and the full data, how it is, what is the minimum value. So This is also known as whisker plot. Why? Because two whisk will be there. That is the min and the max. Okay. And in between min max, you have three quartiles. That is 25%. You see this below line of that box. Middle line is nothing but your median of data. So and above the median, you see the 75%. So median is your 50%. And above the median, it is your 75% data. Okay, so you can clearly tell around 25% data is my, or the bill value of 25 is nothing but falling under 75 percentile. Okay, so this is the best way to get 5-point summary also. So min, max, 25%, 50%, and 75% data, and all those belongs to outlier. So what is outlier also I'll show once I talk about it, statistics. Let's add some more parameters. So control the width first, because it's something which is required to add, because by default it is too wide. So I'll make it 2. Okay, now this looks good. So that's how you control the width of box plot. Now let's add hue parameter. Okay, so I would like to see how total bill is spread across various days. So I'll just use df plot day. Okay, so you see here, why it is not taking. So x equal to df dot day. For each day, I want to have box plot. Okay, that's fine. Okay, so Thursday, Friday, Saturday, and Sunday. Okay, let's control the width also. Dot figure 16 by 4. Okay, looks better. Let's have 5. Much better. Okay, so for each day I got. Now for each graph, I would like to have. So now I'm going to add the 4th dimension. Okay, 2 dimension I already added. 3rd dimension I'm going to add as hue parameter. I want to have between smoking data and non-smoking data. Okay, so df dot smoke. Is it smoker or non-smoker? Let me just check. Smoker. Okay, so now you see here, for each day I would like to get that box plot for smoking and non-smoking versus person. Okay, so that's how you add it. So by this time you would have realized how powerful is this Seaborn library. Okay guys, so that's about Boxplot. Now we have enhanced version of Boxplot, that is nothing but Boxenplot, box enhanced plot. Okay, so what it does, it will just do the box plot, but the way your data is dispersed, right, accordingly that box will be plotted. Okay, so maybe I can just take same example, and I'm just going to remove or add en, that is nothing but Boxenplot. Okay, now you see. Well, let's take one small one. So here, first let's talk about only width. Simple one. Okay, so how your data is dispersed, that is also is getting controlled along with the Boxenplot. Okay, so you'll see here, basically it will show more distribution. Earlier we were not seeing the distribution, right? It was just min max and your interquartile lines, right? But around min max and interquartile lines, how your data is dispersed, more quartile will be shown here. You see more number of quartiles. Okay, so anyway, this is, yeah, so these outliers, and around this, below this particular median line, right, you will have more number of quartiles. Okay, so that is what is your Boxenplot. Let's see the swarm plot. So swarm plot is nothing but to draw data set on box plot. Okay, so if you just do the data plotting here, so here I'm going to take SNS dot, I'll just take the same example. Swarm plot, X is day and total bill. Let's talk about this. Okay, so basically it is exactly, if you just remove these lines and border of this particular graph and just put the data. That is what is your swarm plot. Okay, how your data is dispersed along the given data. Okay, so yeah, nothing much in this. You can have hue parameter here as well. Yeah, so hue is there. So let me add one more. df dot, let's talk about 6. Okay. Yeah. So for each data, I will have male and female separate, how the data is dispersed. Okay, guys, so that's about swarm plot. And now let's talk about Violin. So this is another, so these kind of plot, right? It's all works about whenever you want to see your how data is distributed, go with these plots: swarm plot, Violin plot, your Boxenplot and box plot. Okay. And of course, scatter plot is there. So I'll just use Violin, just name the change the name. Okay, so here, if let me just show the basic one first. Okay, so if you see here, right, it is nothing but your combining your distribution plot as well as density estimation. Okay, and if you see here, the box plot is also plotted, and in the middle you see a white dot, right? That is nothing but pointing to the median of the data. Okay, and that's why you see where is your peak, that is your median. Okay, so from median, how does data disperse? Okay, so above the date, above the median, below the median, correct? So that's what is this. And now if you want to plot or modify a little more details, we have something called, let me just show you. Inner is box, right? So let's see what and all we have under inner. Let me give some name, so I'll get to know what and all is supported. Okay, it is not there, then I need to check the help. So we have not this one, Violin plot. So under inner we have box, quartile, point, stick, and none. Okay, so by default it is none. So let's see what and all we can change. So inner is box, which is by default. Okay, all clear. Now let's talk about quartile. So what it is going to show now, it will show all the quartile data. You see here. So basically this is your median, and this is your 75 percentile, and this is your 25 percentile. So 25, 50, median is 50%, and above that 75%. Okay. Now let's see the next one. We have point, whether you would like to show the point or not. So this is nothing but again your kind of scatter plot without any jitter. So jitter is nothing but it will just spread the data across the distribution. If you don't want to do jittering, then it will just plot in the single strip plot. And this is also known as strip plot basically. Okay, so yeah, that is about point. Now we have next one is stick. Okay, so it is going to plot the stick for each given data. Okay, so whichever works for you, probably you guys can use it based on the need. So that's about Violin plot. Let's see the next plot. Used to plot data over categorical axis. Okay, so we have SNS dot. Let me take same example. So what is my categorical value? X, Y. So day wise, sorry. Strip plot. Okay, you see here. So how the data is spread across and for each day, because I'm giving Y as total bill and X is your day wise, correct? So that's how you can do. And if you see here, there is one parameter, interesting parameter about strip plot is nothing but jitter. So by default, jittering is true. If you make this jitter false, and you are going to get the data exactly the same what you did here, this middle line. Okay. So let's plot it again. I'm going to make jitter equal to false. Okay, so jitter equal to true only required whenever you want to see how your data is dispersed. Okay, from top to bottom, all the jitterness will be given. And you can see, like, basically just to avoid or just to showcase your all overlap data. Here a lot of data is overlapping, right? But you don't want to see that overlap data. Then you make jitter as true, which is by default true. Okay, and I think we will have hue parameter here as well. Yeah, so if you want to have hue as hue equal to df dot, let's say, over gender. But again, if you make here, yeah, see, everything is overlap, right? So in this case, you make it true. You'll see more clarity on that. Okay. Now, what else we can take? Any other categorical value we have? Let's see now. Smoker versus non-smoker. Yeah. Let's talk about smoker. Yes and no. Okay. So that's how you work with Stripplot. Now let's talk about pair plot. So guys, pair plot is also very important, and this is going to be used heavily when you have a lot of numerical data uh, in your data set. Okay, so what it does is basically filter all the numerical columns and try to derive what is the relationship between those numerical data. Okay, so this is one of the best plot to find out the relationships between various features of your data. Okay, so if you see my data here, df.head, so I have here total bill, tip, and I'm talking about only numerical because pair plot is going to take only numerical values. Okay, total bill, tip, as well as size. So we have one function called correlation, right? So I'll just store it under correlation variable, which is nothing but going to be a data frame. Okay, so df dot correlation, that is a function. So I'm going to just get it and just print it. So what it does, basically, it will just find the correlation between total bill versus total bill. So one same versus same will be always one. So it is highly correlated, right? So tip versus total bill, if you see, it is having positive correlation. Okay, so that is correlation factor is 0.67. Similarly, total bill versus size. So okay, so that is almost close to 60%. Okay, so once you get this right, it makes sense to plot data or using the pair plot over correlation. Okay, so what you can do now, SNS dot pair plot, and just provide the correlation value. That's all. Now see the magic. Or without giving this also, you could have given the whole data frame. Anything is fine. So I'll show both. Let it run. Okay, so I think I should give actual data, not this one. This I'll take it for heat map. So what you can do now, df take this one here. Yeah, this makes sense. So what it does, basically, it is trying to find all the numerical values, that is nothing but a total bill, tip, and size. Okay, so total bill versus total bill, that will be like highly correlated. Okay, and total bill versus tip, you see, if you are increasing the total bill, your tip is also increasing. That's what you can infer from the data set, right? You see this x-axis, my total bill is increasing and tip is also increasing. Okay, similarly, you can see the size, total bill versus size, then tip versus total bill, that exactly you'll see. Okay, so basically either you can consider upper diagonal or lower diagonal, both will be same. Okay, so that's about pair plot. Let's talk about the heat map. So there is some limitation here. So if you see, all the diagonal graphs are nothing but histogram, and above and below the diagonal, it is nothing but scatter plot. So how you can do different kind of plotting below the graph sorry, below the diagonal or above the diagonal, or how you can change the diagonal graph property also. That we'll see under facet grid or pair grid, which we'll see in the next Seaborn video. Okay, so when you want to have a quick glance of how your data is dispersed and how your numerical data looks like, pair plot is the best plot. Okay, now let's go to heat map. So heat map, I told, right, we will have confusion matrix in machine learning. So they are like true, false, and true versus false. Okay, or true, false for positive and negative values. Okay, so you will have kind of one 4x4, 3x3, one kind of square matrix, or any kind of rectangle matrix. Anything is fine. So once you have a lot of numerical data, so it is very hard to visualize, right? So their heat map will be showing clear relation between those values. Okay, so to plot heat map, I have just created a matrix here that is pure numerical value, okay, using correlation. And if you want to see or you want to visualize, right, we have something called SNS dot heat map of correlation. Okay. Yeah, so total bill versus total bill, tip versus tip, tip versus size, all those things data. So how they are correlated, basically those can be seen here. So the value which is like very light color will be highly correlated. Okay, so that's what total bill versus total bill. These same values, of course, it is highly correlated and value will be 1. Total bill versus tip, is it really correlated? No. If you see here, tip data is very dark, right? So what does it mean? Darker the data, lower the relationship, or less the relationship, or very less likely it is correlated. So this is the default plot of heat map. Now let's do some annotation, put some values here. We have something called annotate equal to true. So it is going to put all the correlated value against each row or column. Okay, so of course all the diagonal will be highly correlated because they are in the same value. So total bill versus total bill, correlation is 1, means highly correlated. Total bill versus tip, this is almost 68% correlated. Okay, so what exactly you can infer from this data? If your total bill is increasing, your tip will also increase. Of course, those who are paying more bill, they are giving more data, more tip, right? So higher the percent, tip will be more. Now let's say whether this is related or not, you can find out size versus total bill. Okay, so that is also close to 60% related, because more the size, more the bill, correct? Yeah, so that's how you understand the heat map, and you can plot the correlation between the numerical data. Okay guys, so I think it is good enough for today, and I hope you like this particular concept under Seaborn. And I would suggest please start using it, because this is from now on you are going to use it very heavily, because after this I'm going to start exploratory data analysis. So we'll pick up any random data, do quickly visualization using Seaborn, understand what kind of data is there, and how to do the data cleaning. So all those things will be helpful when you are doing the plotting. Okay, and after cleaning the data, you can do better plotting. Okay guys, so that's all about this, and the remaining part I'll cover in the next video. So we'll see what is facet grid, what is KD plot, okay, and what are different variations on those plots. These are very important. Okay, what is joint plot, regression plot, pair grid, and cluster plot. So that we'll see in the next video. Okay guys, that's all for today. I hope you like it. If you don't like, then please put your comment in comment box. And those who have not subscribed my channel, please do subscribe and get latest update on the videos. Thank you so much. Bye bye.